Hey, hello, welcome to the show. It's me, John Park, and this is John Park's Workshop. Thanks for joining me today. I just need to kill the fan over here. It's making too much noise. Oh, it's trying to stop. Hello, thank you for joining me. It's been a short week for me because I was out of town. Just got back last night, so hopefully we've got enough stuff put together for an interesting show today. One note, I don't have a product. I didn't do a product pick of the week on Tuesday, so I don't have a recap of that. But otherwise, let's try to do the usual stuff. So I'll have a coupon code for you so you can save some money in the shop. I will have a CircuitPython Parsec for you, as well as continuing in on and sort of relaunching a new branch of the joystick arcade fight stick project, working on that. And that'll be the bulk of it. So thank you for joining in the chats over in the YouTube. We've got Badagraf Abdelhagen and Dave Odessa, Johnny Bergdahl. Thank you for jumping in. And if you're wondering where the rest of the chatters are, go there. That's our Discord. You can go there by going to adafru.it/Discord and look for that live broadcast chat channel that's right there. And hello to Johnny Bergdahl there as well, Andy Calloway, and Blitz City DIY, C. Grover, Toddbot. I should get you some crouton codes there, Todd. Hey, Thin Man, nice to see you. So what we will start with, as promised, is this coupon code right here. The coupon code this week is Wolfhound, in honor of the cross-country ski race third place winner at the Winter Olympics. A wolfhound, a Czechoslovakian wolfhound, just trotted out. I'm sure you've seen the video by now, but I love that guy. Cool dog. So Wolfhound, that is your coupon code. That'll save you 10% off in the shop today. And if you want to head over there, if you go over to adafruit.com, that is the shop itself. And you can see we've got the products link here at the top, and that includes all the different categories where you can go and look for some stuff, and you will get 10% off if, at the end of all of that, you type in the coupon code Wolfhound. And that will work on all goods, not good on gift certificates, subscriptions, or software, but good on things that we can ship to you. And Andy, I have not. Andy asks, have I fixed my Discord notifications? Let's do it right now. Let's see if I can figure that out. Hold on, because last week my audio was out and everyone was trying to tell me. Notifications, I think that's per server, right? Yeah, I gotta adjust that on this server. This is a good, the Adafruit server is a good server for me to have notifications on. Notification settings, sure. Hey, it is on. Well, that's interesting. Why didn't I hear it? It could be deeper than that, deeper setting than that. Oh well, I'll try to keep an eye out. So anyway, head to Adafruit on the way out, type in Wolfhound. You'll get 10% off on your order. And also, I'll mention, as I like to, if you want to get some free stuff, just spend more money, as I like to. If you want to get some free stuff, just spend more money. So that's counterintuitive, isn't it? But if you go to adafruit.com/free, you'll see our enticements for you to spend more money. If you spend $99 or more, you're going to get the free PCB coaster right there. If you spend $149 or more, you'll get the coaster as well as a free KB2040, which I'll actually be using today. I'll be going over some KB2040 pinout stuff as we look at this joystick project. And then if you spend $199 or more, you'll get the coaster, the KB2040, and in the continental United States, you can get free UPS ground shipping. Andy, I did not get a notification from that. I must have suppressed all notifications from Discord at this point. Let me try to turn that back on. I think I can live with a few dings. Let's go to my system settings. Probably there. Let's go to notifications. Liz is suggesting it could be a deeper setting than that based on streaming mode. Okay, Discord. Yeah, I'm allowing notifications. All right, who knows where I put that? I'll keep my head on a swivel. I swear. So that is the enticements. That is the coupon code. Which, by the way, over in the chat, it was mentioned. Yanisku7 said Nazgul is the wolfhound dog. Nazgul, cool name. Okay, what next? As I said, I don't have a recap of a non-existent product pick of the week show from this week. It didn't happen, but I will be back next week with a new product pick of the week. So tune in for that. And let's get going with a CircuitPython Parsec. CircuitPython Parsec. Okay, let me swap views over to this. Here we go. For the CircuitPython Parsec today, I wanted to show you how to turn a NeoTrellis grid into a scoreboard for your Wordle game. Could apply to other games, but if you play the New York Times game Wordle, or an alternative version of it, you will know that it is a 5x6 grid, which is scored with either blanks when you don't get a letter right, yellow when you have a correct letter but it's in the wrong position, and green when you've got the correct letter in the correct position. So when you play the game, you're usually given something like, let me copy and paste one here out of my chat. So here's a typical, you can see up at the top here, I'm just going to paste it in. So there at the top, you can see that's a typical grid you might get after playing the game. It'll say, okay, here's where your positions were. And you might want to copy and paste those and share them with your friends over text, so it has some functions for that. But if you want to stare at it all day long and be proud of what you did or live in shame and vow to do better the next day, you can use this to do so. So you'll see here I have a sort of simple pixel art program that I've created that uses the NeoTrellis, or MechaTrellis in this case, grid, the buttons to record when you've pressed a button, a little bit of logic to cycle between either off, green, or yellow for the different states that the game can be in, or the answers can be in. And let's take a look at how this is done. You can see also I have part of the canvas here that's not used, and I just lit those up with sort of a pale blue. So what I'm doing in here, again, I am importing the NeoTrellis as well as the multi-trellis library, and I have 4 of these MechaTrellis/NeoTrellis boards stitched together over I2C with 4 different addresses, so I can treat this as one 8x8 grid. And then I'm going ahead and setting up some colors I'm going to use, a sort of mini grid within a grid. So I'm saying that my Wordle grid starts at upper left corner here, 0, 0, and is 5 wide by 6 high, so x, y, axes here, width and height. And then I create this array so that we can work within that, all of the possible positions within that. So I'm tracking the state of those with this array called Wordle grid, and that creates a 5x6 array so we can store values. Then I also have some helper functions like position to x, y. This will turn any 0 through 63 on this grid into an XY position, and I just use that to cycle through them at one point. Sometimes you'll use either the XY or the 0 through 63 in your code, depending on what's more convenient. And then I also have a little check here. When I press a button, I don't want anything to happen on this canvas, so I check to see, is the pressed button inside of the Wordle grid? So this checks to see the start and end position and compare that to the 5x6 row. Then we get the color for the state, so that you'll see here I set up a little set of black, yellow, green, and the canvas color. So the state can be either 0, 1, 2, or back around to 0, and then I've just correlated a color with those. We initialize the display at first by running through the full range and setting it to either the black or the canvas color. And then I have a function here which is called handle button. So what this does is when we're running the main loop, we'll sync up the neotrellis and look and see, did a button get pressed? Was the edge rising? So when we press it, the edge rises, and we kind of ignore the drop down when we let go of the button. If it's in the Wordle grid, then we say the grid X is equal to X minus the Wordle start position, and the grid Y is Y minus the Wordle's Y position. And then we go through all of them and set their colors, and you can see here, so Wordle grid Y grid X is equal to the grid Y grid X of the stored value. And then we can wrap through by doing this modulo 3. So that's what allows us to go, every time I press that, through one of those values. Then we update the LED for those colors, just checking to see this 0, 1, and 2, black, yellow, and green position. And then the setup here that I mentioned before, using this XY pause to XY, is what sets all of those at the beginning, sets these keys to be active so that we can press them. And then the main loop of this is just simply the trellis sync, just like some of the other examples we've seen before. That's a convenience of the trellis library, is that it can just wait for events to happen and then run the other functions. And so that is how we can set up a, let's do a very triumphant one here. Let's get it in, I've never gotten it in 1, but let's say we got it in 2. There's a triumphant Wordle score there. And so that is how you can set up a little toggling pixel art canvas or Wordle scoreboard inside of CircuitPython on the NeoTrellis or MechaTrellis board. And that is your CircuitPython Parsec.
CircuitPython Parsec.
All right, and so I actually have some other drawing on the screen stuff that I want to do, and icons, building up to being able to use this for some different MIDI projects, but I thought just exploring this sort of thing of using subgrids. It's pretty common in this grid-based interface in MIDI things, drum triggers, to set up little mini quadrants or other sections that are maybe little piano rolls or piano keyboards in different octaves. So being able to sort of subgrid this out, I thought was pretty useful. So that's one way to do that. Okay, next up, let's start digging into the from scratch arcade joystick project. So just to reiterate or catch you up, I had gotten this pretty inexpensive, unplug this, used old joystick from the year 2007, I think. Replaced these buttons because it had lame, squishy kind of buttons. So these are real mechanical switch buttons here. The joystick was good, left that alone, left these buttons alone. But I'm using the original microcontroller in this largely because the microcontroller already handles sending out PlayStation 1, 2, and I guess 3? That might just be, yeah, I think PlayStation 1 and 2 over this connector and USB over this connector. Works well for that, but leave that alone. But I wanted to build a arcade fight stick from scratch. So joystick, bunch of buttons, and a RP2040 based microcontroller. So what I want to do is show you the, first I'm going to show you I got to share a screen here, the fritzing layout of what I'm putting together. I think it'll make the most sense since it's mostly on a breadboard at the moment. So let me do a new screen capture of fritzing here. 1 second. Or that. Let's go to a single window. Actually, I think if I call it a game, it does a better job of showing interaction. So let's go to the game of fritzing. And I just have to not overlap these windows. So let's pull that out of the way and move that there. And I will move me for a second. Okay, there you go. So this is the idea here, is that I'm going to have a KB2040 at the heart of things. Sorry, the mouse interaction here is really fast. So I have a KB2040 set up here. I won't go over this wiring because it's a bit bonkers, but it was more important actually for me to put together the schematic for this and then the PCB. So this is a difficult diagram to look at right now. I'll try to clean it up for the guide. But you can see here I've got the KB2040. I have a nice little OLED screen connected over the STEMMA QT I2C. And then I have all of my pins that I'm going to use on the KB2040 going to some little screw terminal blocks. That's what these are here, is these little these little blocks of 10 on a 0.1 inch grid. And you'll see this is maybe not the typical way to do this, but I want to make it really clear and convenient. So rather than tie a daisy chain of ground between all the buttons, actually sometimes that's annoying to wire up. So I've given myself, for every GPIO pin of a button, you can see I have a neighboring ground pin. So this yellow line and black line here are, let me see if I can move this. It's going to want me to zoom out. Are going off to this white arcade button right here. So that's using, if we zoom in here, this yellow wire goes up to pin, I believe that's 0, digital pin 0 on the KB2040 there. But this is where I was able to actually make things clear, was in the schematic view here. So you can see what I've done here is I've gone and created all 4 of these little 10-pin screw terminal breakouts, run those to the KB2040, which is actually laid out pretty much like the real board. Oh, I'm so sorry, that's zipping around. So there you can see we have on the KB2040 the D plus and D minus at the top are actually USB breakouts, which I'll have as an option on this board. And then raw is the 5 volts coming from USB here. And then all of the digital pins and a couple of ground pins. So D0, D1, D2, D3, these are all running over here to the screw terminal, which then runs off to buttons. Let me see if I can get a good, there we go. So you can see these are these arcade switch buttons here. All run a pair of ground and GPIO over to the KB2040. Then also, if I carefully zoom in here, you'll see that I have the I2C breakout to that little OLED there. And I think that's it. I don't think I used a separate, yeah, other than arcade switches and a reset button, that is all that we're breaking out to. So then what I did was I took that, and let me hide these rat's nest lines here for a second. I took all of that, put it on a PCB. Now, The arcade buttons, also some NeoPixels I forgot to mention, and the OLED, those have a footprint. You kind of can't help it, but I just wanted them in there to know what I was hooking up to, so I've got those things sort of hanging off the edges of my PCB. So they have to be there just for clarity. I could make a version of this where I delete them, but for me to have a sanity check. And what this is just a nice little KB2040 screw terminal breakout that's got silkscreen on it so that we know what to hook everything up to. That'll allow me to use this as the little brain and then hook up all my buttons and joystick, screen, and NeoPixels to these screw terminals that are nicely labeled. So you can see here, I'm going to actually hide the silk, or rather the copper layer on the top. Because bottom layer is where most of these connections are made. And so here you can see, just inch this up a little bit, you can see the KB2040 starting at the top left corner there. I'm running the data plus and minus the raw power, the 5 volt, and the ground over to a little sort of standard header pin section, so I'll be able to solder on a USB breakout to that, like a panel mount, that kind of thing, if I want to have a removable USB cable, or we can just use the USB-C that's on the KB2040. And it's pretty typical to hang the board off of the edge of the PCB so that we can get a nice exposure to or access to the USB-C on the KB2040. But this, again, looking at the bottom of the board where all these traces are going, I've got my D0 here going out to a screw terminal on the screw block, as well as this ground plane is taking care of all the ground pins, so I didn't have to route those. And then this is just what they're going to represent inside of the GP2040 CE software, which has sort of its own standard namings. I'll show you that in a second. But A1 I'm going to use as the sort of home button. A lot of controllers have something like a home or the PlayStation button or the Xbox button. If you have it hooked up to your Mac, that'll bring up the Mac mission control or something like that. So A1, I've got A2 is sort of a freebie button that I don't need to assign to anything, so that's just an extra. But B2, B1, B4, B3, those are the main 4 buttons. I have a function button, which is just used for some housekeeping on the controller itself, like being able to go into a settings mode or switch between having it act like a Switch controller or an Xbox controller, etc. Then I will have a pin for the NeoPixel in, and then I have a 3 volt and a ground right below it. Oh, did I screw that up? No, I think one of those is on top and one is on the bottom. Hopefully not. I haven't gotten these boards in yet, but I might. Looks like there's a possibility I put a 3 volt to ground there. that'll be bad. So we'll look at that when I get it in. And then over on this other side, kind of working from the bottom up, we have the R2 and L2, R1 and L1, and then the S1, which is the select button, and the S2, which is the start button. And then we have all of the joystick stuff up here, so right, left, down, up, and ground. And if I zoom out a little bit here, if I take that top layer and turn it back on. Okay, good. I think, yeah, I did okay. Top layer is 3 volt. So I did the bottom layer plane as ground, and I did the top layer plane as 3 volt. So it looks like I was just confusing myself, but yeah, the 3 volt goes to 3 volt. So this should be my NeoPixel stuff right here of NeoPixel data, input, 3 volt, and ground. So yay. I do have reset broken out, as you can see here, so I'll be able to put a reset button externally. And I think that covers, yeah, that covers everything that's on there. So what this will look like, let me switch over to the down shooter. It's basically, right now we're in this sort of state, right? So I'm going to unplug something and go to the top view here, or the down shooter view here. Let me move this little breadboard into space. And let's go to that down camera there. So this is what development usually looks like for me with these kind of joystick projects. Is I've got the KB2040 or Pico. Those are really typical to use. I'm going to boost the exposure here. Let's see that a little bit better, yeah. And then I have some of my jumper wires kind of permanently connected so I can just boot into configuration mode. And then some just hanging free so I can test out button presses. So let me disconnect that clock one, and I'm going to reset the board. Or so I say. Let me power cycle the board. Okay, so you can see here, we've got a little splash screen, and I think we can change that. I'm going to look at putting my own splash screen there. And let me tighten that focus. So this OLED, I've never used one in a joystick, but it's kind of neat. First of all, it gives you a little representation of 8 buttons on the joystick. So if you remember from my PCB layout, you saw there the upper right digital pins were joystick pins. So if I touch A0 and A1, you'll see that little joystick icon go from center to down, center to right, up, left. And then some of these aren't represented, like the L triggers, so you won't see that show up. But if I come over to the other side of the board, you'll see the buttons 1 through 1, 2, 3, and 4 are over here. So you see those lighting up as we press those. Now, that's fine, but actually the reason I thought it'd be worthwhile having a function button separate and the screen on here is, and we'll just see this right now by having me reboot it or reset it. Let's see, yeah, so if we're holding down a certain button or button combo, right now it's the, I think that's select button, when we start up, then we get a little web config on our OLED here. So we can go through and do some configurations, set it into different modes, and have a little screen for that, which is cool. Since I don't have buttons set up to navigate that right now, what I'll do is show you the, let's go to, I'm going to go over to the web view. Where did I put that window? Hold on. Okay, there it is. Let me share this view. Here we go. Yeah, I can see that. Okay, so here what I've got is just a split view, 2 pages from GP2040, which is really the best, most popular, as far as I know, open source game controller and joystick and music instrument controller firmware for RP2040 based boards. I've done projects before mostly on Pico with it, but I decided to use KB2040 for this one for a couple of the conveniences like USB-C and the Stemma QT port for my little display there. Along the left here you can see this is the wiring pin diagram for a few different microcontrollers. And so here if we look at KB2040, there's the A1, A2, B2, B1, B4, B3. So these are kind of the defaults. You can change these, but these are the defaults, and that's what I went with for wiring up the sort of physical pins to the logical pin usage on buttons. I did change some of those. So if we look over here on the right, this is the web configurator. So when I booted this into this config mode, this now runs a little web server where we can go in and adjust things. So I'm going to squeeze this a little smaller over here. And so if I go to, well, if you see what's listed here right now, it says we're on a KB2040. We're running this version of GP2040. How much memory is used, excuse me, how much flash is used. If we go into this little drop down here into configuration and go to GPIO pin mapping, so this is showing me this correlation between physical pins. So GP0 is the pin labeled, I think, TX on the KB2040. So that's also known as GP00. I think that's also known as D0 in CircuitPython. So that pin, you can see there, is what's going to go to the A1 pin, or that home pin, that Xbox button pin, or that PlayStation button pin. And we can go and say, oh no, it's something totally different. So every possible thing this can be, oops, I'm going to screw it up by adding them, can be a GPIO pin on here. And some of them can have multiple duties. There's also macros that we can use. So this is one profile. So one of the interesting things of having that little OLED screen on there is you can pick profiles. So with like a function key in my joystick, I can navigate that and say, I'm going to use profile 1, which is set up for a fight game on a PlayStation, but then maybe I want a different layout for a different type of game on a different system. So you can have different profiles on there and then pick them with the little OLED there. So these are my main button assignments. You'll also see there's a couple special ones on here. I have GP7 as assigned to add-on. That's what I have my NeoPixels going out on, which I think don't have a default. Or if they do, it's for the onboard NeoPixel, not what I wanted. So if I go up to configuration peripheral mapping, you can see here we have pins selected for I2C. This is how I'm using my OLED, and I think it's LED configuration. My data GPIO pin here I set to pin 7. So that's what these sort of non-standard GPIO pins are. Pin 7 is assigned to the NeoPixel, and then this pin 12 and 13 are assigned to my OLED, which I think by default those are on R3 and L3, which is like clicking your analog sticks on a PlayStation controller, and I'm not using that at all on this. There you can see my GPIOs for left, right, up, down on the joystick. So you could adjust this wildly if you wanted to plug things in a little more directly. Excuse me, but I, again, went mostly with the default on this. Other things that we can do in here are, besides the LED pin, we can pick the RGB order. So GRB is pretty typical for NeoPixels. And then the layout, is it a predefined layout or your own custom layout? So when they say stick here, they're talking about a joystick-based arcade button combo where you're going to light up each button, for example. How many LEDs are in each button? What's your maximum brightness? How many steps of brightness for things like fade? And then your buttons that you're going to actually put an LED in. Since I'm using the, let's see, I don't have one here. Sorry about that. I'm going to use our little short buttons for this that don't have a built-in LED because I want to have NeoPixels, I want to have color. So I'm going to probably shine them through from the side, attach them to the side. So we'll look at that next time. But here I have what buttons I want to have lights on, and these are the available ones here. You can also do just case lighting and that sort of thing. Here's case RGB if you just want kind of ambient glowing. So we'll take a look at that in greater detail once I get that put together, once we start putting that together physically. And let's see, other configuration that we can do, create custom LED themes, the display configuration. So here you can see you can, it's kind of baked into it. We can use these different drivers. So the SSD 1306 is the driver on a few of our little 128 by 64 OLEDs. So that's what I'm using. I think this is the 1.1 inch one or 1.2 inch one. And you've got some screen options for flipping it if you had to change the orientation, mirror it if for whatever reason it's come across strange. You can invert the display as well, black and white to white and black. Layout options, I haven't messed with that for the display. And same with mode options. Here's the custom splash screen that we can put on there, which will be fun. And let's see, other configs we're going to do. I think the only one I added, or maybe I didn't need to. Yeah, so I'm going to, like I said, have the menu, and I'll have a function button so that I can work with the menu on the little OLED. Macro configurations I'm not using, but you can set up custom things to happen based on multi-button presses. And then you can back up the data on there. Other than that, yeah, so input mode, this is the boot up thing if you want it to act like any of these types of controllers, depending on what you're going to plug it into, and then you can swap among them on startup with a button press. So let's look at it in sort of in action right now. So if I go to controller tester, or gamepad tester. So I'm going to take this out of let me go to a screen you can see. One moment. There we go. So now I'm in sort of actual game mode. So if I use any of these buttons, you'll see the gamepad tester wakes up and says, "Oh, okay, you've got a game controller plugged in, and it's called the GP2040CE." So as I touch some of these right side of the screen buttons here, you'll see those get pressed there. Just got to be careful not to short this thing. I don't think anything's a 3-volt down here. So yeah, I won't tempt fate too much with that. Let's see. I think this one is like a, yeah. You can see there's the L1. Oh, I restarted it. I think I hit reset. Oh, I also just, you didn't see this, but I pressed that S2 button, which or that home button, which brought up my Mac mission control. So my screen just went crazy. So that's that just in basic testing. And so the next thing I'm going to do while I wait for, I sent off to have those PCBs made. While I wait on those, I'm going to put together, I didn't have time to solder this up, but I'm put together a little super small button tester here. And I'm going to, I think, use one of the, we have these little 5-way navigation switches. I'll show those on our web page for them. So I can use that as a joystick and some of these buttons just to have a little tester that I can solder a whole bunch of wires to and plug into this thing, or offload it out to the same 0.1 spacing screw terminals. So let's actually look at those. Let me go to, bring this back on. There. So if we go to Adafruit, so I'm going to have navigation. So this through-hole 5-way navigation switch really is a joystick. It's works the same as the arcade joystick, as far as I know. We just have tiny 4 little cardinal direction switches, and this one actually also has a 5th switch, which is pressing the whole thing down, which I probably won't hook up because that's not how my joystick will be. but one of those and a bunch of, or 4 of these 0.1 terminal blocks. If you take a look at these, we have them in the 10-pin variety. That's going to use. You can also do, if you want to hook up arcade buttons without using the screw terminal, and I may make a variation on this, you can use our little crimp connectors that have a JST plug, and we sell the JST breadboard and proto board friendly connectors that you can plug those into. I may use JST sort of pigtails on mine in the screw terminals as a sort of easier way to make the connections when actually threading this through and plugging it together. So what else? Those are the main things. I'll probably also do a version of this that's the Pico, almost the same setup, but just wire it for the Pico because people like to use that too. So those are going to be my my joystick components there. I'm going to use mostly these type of push button momentaries for select, start, home, function, and then only 8 of the buttons will be full arcade switches. And those will be these 30mm arcade short snap-in ones, largely because I did not want to do just single color LEDs, and there's not a good way to control all of those without adding a PWM breakout of some kind to handle a whole bunch of buttons. So NeoPixels will make that much easier. And not sure which NeoPixel solution I'll use yet, but I think there are some Ruiz Brothers projects of turning arcade buttons into RGB NeoPixel buttons, so I'll take a look at those. Let's see. Anything else? I think that covers what I'm doing with that. Let me know if you have any questions in the chats. And I will be putting together also let me move that screen back there. Hold on. Putting together a enclosure for this to use our joystick as well as those buttons, and that's just this nice clicky arcade joystick right there. So that'll go in and that'll handle 4 directions of clicking. All right. Before I go, since I just mentioned some stuff you can go buy if you want to prep for making yourself a arcade joystick or something else, that's the coupon code for today, Wolfhound. That's going to save you money in the shop. Thanks for coming and hanging out. Sorry it was a slightly shorter show just because I was out all week, so I didn't have a ton of time to prepare for it. But I will be back with a new product pick of the week on Tuesday. I should mention, I believe Scott is doing a deep dive tomorrow, Foamy Guy on Saturday. There may be more Desk of Lady Ada things coming out. She's been doing some neat hardware designs. I'm really excited about a little tease of a Cutie Pie screw terminal breakout, which is just what the Cutie Pie needs, I think. And then there will be a, as I said, Tuesday product pick of the week, Wednesday 3D Hangouts, and then a show and tell on Wednesday evening. So come on by for all of that, and thanks for coming to the workshop. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. See you soon.
You